This is Chapter 5, Lesson 5, the Pythagorean Theorem. All right, so the Pythagorean Theorem is for finding the length of the missing side in a right triangle. So the Pythagorean theorem is for finding the length of the missing side in a right triangle. Okay, Pythagorean theorem only works for right triangles. Remember, a right triangle has to have one right angle. Okay. So over here, I have a triangle. It wants me to label the legs and the hypotenuse. Okay. So, trick. Hypotenuse is always across from the right angle, and it's always the longest side. So in this case, here's my right angle. My hypotenuse is directly across from my right angle. So this is my hypotenuse. And my legs are always attached to the right angle. So here's my right angle. This side's a leg, and this side's a leg. Okay? So again, the theorem only works on right triangles. Okay? So, the reason it's called Pythagorean theorem is actually it's named for a mathematician named Pythagoras. So Pythagoras was a Greek philosopher and mathematician. Okay, and he is famous for the Pythagorean theorem, among some other things, but that's what his big thing is. Okay. So this is an example of the Pythagorean theorem. So it says, use two colors in the square grids to show that the Pythagorean theorem is true. Okay. So I'm going to use pink and green. So, basically how this works is I have 3 squared, right? So there's 9 total boxes here on this side. Because basically what it says, what the Pythagorean theorem says, is that each of the legs squared, and you add them together, equals the length of this side over here. So I have 3 squared, so that's 9 squares. And then a length of 4, so 4 squared. Which is 16, right? Okay. Well, there's 9 of these here, right? And there's 16 here. 9 plus 16 gives me 25, and there's 5 squared here. So that means that this actually does work, because square root of 25 is 5. Okay. So here's my 9 squares, right? Okay, and if I count on the outside, I should have 16 squares on the outside. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So, again, I had 9 that were here, 16 here, and so I have on this side, because this plus this is supposed to equal this. Well, 9 plus 16, there's 16 green squares and 9 pink squares equals 25. So 3 squared gives me 9, 4 squared gives me 16, and 5 squared gives me 25. So this is a proof that it actually does work. Okay. So the theorem is a squared plus b squared equals c squared. Okay. Now each letter represents something different. A and B represent the legs. C represents the hypotenuse. Okay, so the area, go back up to my drawing, right? The area of C, which in this case C is 5, the area of C, so 5 times 5, equals the area of one leg plus the other leg. So the area of this equals 9 plus 16. Okay, let's take a look at some examples. So, example 1 says a right isosceles triangle has legs 6 meters long each. Find the length of the hypotenuse to the nearest tenth of a meter. Okay, so I'm actually going to draw this triangle. Okay, so first it tells me that it's a right isosceles triangle. So a right isosceles triangle, okay, and has legs. So my legs are the ones that are attached to where the right triangle is, of 6 meters each. Okay, I want to find the length of my hypotenuse. So my formula, a squared plus b squared equals c squared. So I'm going to take a is 6, so 6 squared plus what my b is, 6 squared equals c squared. 6 squared equals 36. (36) plus 36 equals 72. Okay, so now I have 72 equals c squared. Okay, so what I need to do is, because I have 72 and I have c squared here, in order to undo the square, I have to take what's called the square root. So I take the square root of both sides. Okay, and you can do these on the calculator, so let me show you on the calculator. Okay. So, right here where the square is, there's a little tiny green, in this case my calculator is green, square root. So I'm going to take the green second button, and then I'm going to hit the square button, and it gives me the square root. I'm going to type in my number, 72, close my parentheses, and press enter, and it gives me 8.485, okay? So that means C equals 8.485, and it keeps going, right? So it said round to the nearest tenth of a meter. So my answer is going to be approximately 8.5 meters. Okay, I want you to go ahead and look at example 2. So the first thing I want you to look at is they've given us a triangle and they want us to find x. So, are you missing a leg or a hypotenuse? In this case, you're missing a leg. So, when I write my formula, I can replace A with x, B with 8, and C with 13. So now I'm going to take and go ahead and simplify. 8 squared is 64. And 13 squared is 169. Okay. Now I have x squared over here. I want to get x squared by itself. In order to do that, I have to get rid of the 64. The opposite of addition is subtraction. So I'm going to subtract 64 from both sides. 169 minus 64 is 105. Okay. Now I have x squared equals 105. So I'm going to take and I'm going to square root both sides. So I'm going to use my calculator. Square root of 105. So x equals 10.24, and it keeps going. So I'm going to go ahead and round. So x is approximately 10.2. So on this page, there are a couple of try it problems. I want you to go ahead, pause the video, try them out, and then we will go over the answers together. All right, now that you've had a chance to try out the try it problems, let's go over the answers together. So the first one I have is this a right triangle? And it gives us 3 measures. Side lengths of 8 centimeters, 10 centimeters, and 16 centimeters. Okay. So the first thing that I want to figure out is which ones of these are the legs and which one's the hypotenuse. You can remember that the hypotenuse is always the longest side, which means 16 has to be my hypotenuse. So my formula, a squared plus b squared equals c squared. I'm going to plug in 8 for A, 10 for B, and 16 for C. Okay? Then I'm going to solve each side. 8 squared is 64. 10 squared is 100. And 16 squared is 256. 64 plus 100 is 164, and that does not equal 256. So the answer to this is no. These 3 side lengths do not make a right angle. My second try it problem says find the length of the diagonal. So this is a rectangle. So rectangles have 4 sides and 4 right angles, okay? So this right angle, this is a right angle, this is a right angle, and this is a right angle, okay? So I now have a right triangle. The diagonal is my hypotenuse, and I'm already given my 2 legs. So my formula, a squared plus b squared equals c squared. I'm going to substitute 4 for A, 11 for B, and I'm going to leave C there. Okay, now I can simplify. 4 squared is 16. 11 squared is 121, and that equals c squared. This then gives me 137 equals c squared, and I square root both sides. The square root of 137 gives me c is approximately 11.7, and I'm going to round to the nearest tenth. And it's in inches, because that's what they gave me in the triangle. So, the theorem works both ways. 1, if a triangle is a right triangle, then a squared plus b squared equals c squared. If a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, so we kind of saw up here with this example, a squared plus b squared did not equal c squared. So this was not a right triangle. Okay? So a little bit of history. Although Pythagoras is credited with the first proof of the Pythagorean theorem used in Euclidean geometry, it is believed that Babylonian, Mesopotamian, Chinese, and Indian mathematicians understood the concept before his time. There are many proofs of the Pythagorean theorem, including both algebraic and geometric proofs. Okay. So the final example that I want to look at is find the distance between the points 4, -3, and -2, 1 on the coordinate plane. So go ahead, pause the video, try out this problem, and then we'll look at it together. Okay, now that you've had a chance to try out this problem, let's look at it together. So the first thing that I want to do is actually plot the points on my graph. So the first of my points is 4, -3. 1, 2, 3, 4, 1, 2, 3. So it's right there. Okay. And the second of my points is -2, 1. So -2, 1. Okay. This actually can form a right triangle. So there's my right triangle, okay? So I can figure out this distance and this distance. Well, this is 1, 2, 3, 4, 5, 6 units. And this is 1, 2, 3, 4 units. Okay? Then, of course, I have this distance, which is one that I don't know. But I have 2 legs, so I can figure out the hypotenuse, which is the distance I'm looking for. So I have a squared plus b squared equals c squared. A can be 4, b can be 6, and we don't know c. 4 squared is 16. 6 squared is 36. Which gives me 52. I square root both sides. So C is approximately 7.2 units. And that is the end of lesson 5. All right, on the next 2 pages, you have more Pythagorean practice problems and the coloring sheet, okay? So I want you to go ahead, work on each one of these problems, okay? Then do the coloring sheet, and then we'll check the answers together. So I want you to look at the first one, okay, because I want to make sure you understand what you need to do. So the directions say find the missing side length, show all steps, color the problem numbers with its color in the picture. So for number 1, if I solve this and I were to get 8 meters, then I would color anything over on my picture that's problem 1 as orange. So for example, here's a 1, so I'd color this space orange. Here's a 1, I'd color this space orange, okay? If it was 11.6, I would color number 1's purple, okay? So you will get one of these 2 answers. If you didn't get one of these answers, then you did something wrong. Okay, so make sure you double check and you go back through and you show all of your work. You're probably going to need a separate piece of paper for it. This is what your Pythagorean practice page should look like after you are done coloring it.